If this is your first time visiting me, welcome to 6-Minute Statistics. If this is a return trip for you, welcome back. Now would be a great time, if you haven't already, to subscribe to my channel so that you get notified when I produce more videos. In this video, I want to cover the idea of our random variable. I'm going to try to explain what it is in simple and straightforward language. And as always on this channel, I'm going to try to do it in about 6 minutes. Are you ready? Let's go.
Give me 6 minutes and I'll teach you something new. Now, let's get to work.
Mark here from 6-Minute Statistics, and I want to begin with a short conversation about what else? Tattoos? Yeah, tattoos. My people are not a tattooed group of people. The Dummeldingers, my dad's name, and the Gumps, my mother's maiden name, shocked that she didn't hyphenate. Gump Dumbeldinger would have been epic. But anyway, they're both pretty conservative families when it comes to body art. So when I met my wife in 2011 and she introduced me to the wonderful world of tattoos, it was all new to me. About the same time, I read an article that claimed 30% of all college students have a tattoo. As with many times when I read a statistics like this, I want to question it. There's this natural, cynical, or quizzical part of me that's wondering whether those numbers are accurate or not. Well, fortunately for me, in my day job, I'm surrounded by lots and lots of college students. So since that time, I've been asking the college students that I work with whether they have a tattoo or not so that I can check that value. Now, I'll come back to that idea in a minute. At its core, random variables are about outcomes. I've done several videos recently about probability where we're interested in learning about the chance of an outcome or an event occurring. Random variables step in when probability outcomes get tricky. Let me explain. If I ask you whether you have a tattoo or not, you're either going to tell me yes you do or no you don't. Simple. What if I ask two students? Well, when I ask two students, there are 4 possible outcomes, right? Either they both do have tattoos, or they both don't. Or maybe the first one does and the second one doesn't, or the other way around. The first one doesn't and the second one does. I think I got that right. A little more confusing, but we can still keep track. What if I sample 5 students? See where I'm going here? The different combinations of outcomes get tricky to keep track of. Turns out when I sample 5 students, there are 2 to the 5th, or 32 different ways to order which students have tattoos and which don't. I typically use symbols like N, 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 N to indicate that none of the 5 students had a tattoo, whereas T, T, N, N, N would indicate the first 2 students do have tattoos and the last 3 do not. As the sample size gets larger, the total number of combinations skyrockets. Take 2 to whatever the sample size power is, so 2 to the 50th power, 2 to the 10th power, and you're going to see the numbers get big really, really fast. It gets way too difficult to keep track of outcomes. This is where a random variable steps in. Simply put, a random variable is a variable that assigns a number to the various outcomes of an experiment. For instance, let's let X, that's typically how we denote random variables, equal the number of students with a tattoo. In the case where we sample 5 students, the values of X are either 0, 1, 2, 3, 4, or 5. There are only 6 possible values of X, even though there are 32 different possible combinations of the way students have tattoos or not. In essence, random variables group our probability outcomes based on the value of X that is observed. Think about taking the 32 different probability outcomes and sorting them into the 6 different outcomes based on X. For many applications, knowing a value of X is way more important than knowing the individual combinations that make up that value of X. For instance, you might be interested in what's the chance one student in a group of 5 has a tattoo. It's more unlikely that you're interested, what's the chance the first student has a tattoo and the remaining 4 do not. Random variables are going to prove extremely useful as we move forward. Now, there are 2 types of random variables that we need to identify so that we can work with them. The tattoo example is a great example of what is called a discrete random variable. A discrete random variable assigns a countable number of values to the outcomes of an experiment. If I sampled 10 students in the tattoo example, the values of X would be 0, 1, 2, 3, all the way up through the value 10. Notice there's 11 different values. Notice also that we can never have a value of 2.5 for a value of X. A student either has a tattoo or they don't. Discrete random variables have to land on the specific values that are assigned and nowhere else. The second type are called continuous random variables. This type can land anywhere. Sometimes there are limits to where the random variable can land, but it can be anywhere in between. For example, Old Faithful is probably the most famous geyser in the United States, maybe the world. It erupts up to 20 times per day, and the time between eruptions is typically between 40 and 120 minutes. We can define x to be the time between eruptions. Because x is not restricted to whole numbers, we're going to say x is a continuous random variable. The length of time of my videos, heck, time in general, is considered a continuous random variable. When you look at my YouTube thumbnails, you're going to see that this video is 6 minutes and 58 seconds. But is it really? Isn't it 6:57 and a half or 6:57 and 3/4? Time is going to be a continuous measure. The number of videos I post in a month is going to be a discrete measure. It's either 0 or 1 or 2 or 3. The amount of soda poured into a 2-liter bottle would be continuous. It doesn't have to be 2,000 milliliters or 2,001 milliliters. It can be somewhere in between. It's important to know that whether we're dealing with discrete or continuous distributions because the techniques we use to determine probabilities change based on the type of variable we're working with. But more about that later. For now, just be able to identify whether a variable would be better described using discrete or continuous variables. And that's a great place to stop. Up next, I'm going to add probabilities into the mix, but until then, take a look at some examples. Wait for it, wait for it. It's time to get to work.